Now, to see how close we can get to a calibration curve using this data, we just transfer the soil test value on the x-axis and the relative yield on the right axis, so on the vertical axis. So for site 1, soil test value of 20 and relative yield of 100. So a non-responsive site. Site 2, soil test value of 6 and a relative yield of 58, so 6, 58. Site 3, soil test value of 11 and relative yield of 81, so 11, 81. And for site 4, the lowest nutrient value of 3 and a relative yield of 39. Okay, so you can start to see the curve developing, and if I plot all those 14 points, this is the end result. You'll see there's a nice curve in there that should have a reasonable R value. There's a couple of outliers. Number 11, which is site 11, which had a soil test value of 14, so that should have put us up in here somewhere, up in this range, but in fact it's only got a relative yield of 48%, so it's an outlier. And site 12 was the other one. It had a less than moderate soil test value of 9, yet it gave 100% yield. So we've got a pretty good calibration curve there with a couple of outliers. Now the interrogator doesn't take out the outliers, it leaves them in there. Okay, and you might be able to take them out by using some of the filters, but they stay in there. Now the other thing it's asked for is the other thing that the interrogator does is give you the critical values at 80%, 90% and 95% of relative yield. So in this case here, at 90% relative yield, the critical soil test value is about 15 milligrams per kilogram.